All right, we had a request for question number 27 off of the study guide. And I'm going to make this official right now. In the multiple choice section of your exam, none of the questions will have more than 6 answers. That's a promise. So clearly this one fits. It's got 4. That doesn't mean don't study the questions that have more than 6 answers, people. I'm going to cut them down to 6 answers. All right. So we better know what acetylene is or we're in trouble. That's true for the whole semester. Its name is very misleading. It's really F-ine, E-T-H-Y-N-E. Step 1, hey, it's review time. Sodium hydride is NaH. This is step 1. Acid base. Step 2 is a synthesis step. Yes, we have to know what a benzyl group is. It took some people by surprise on our last test in the nomenclature section. Please don't let it take you by surprise again. Benzyl is to phenyl as allyl is to vinyl. They're analogous. So the vinyl is just a C-double-C, and the allyl has an extra C before that. A phenyl is just the benzene ring. A benzyl is the benzene with a carbon before that. So the bromine is attached to a carbon before a benzene. There's your benzyl bromide. And I'm going to assume you know that in Orgo 2 from day 1 as well. We use benzyl bromide on at least half the tests, or benzyl something. So your synthesis gets you here after step 2. Pretty exciting stuff. You made a new carbon-carbon bond, and here's your short form. Notice I got the extra carbon right there. There's a dot. And then 3. Same story about acid base, but we're doing it on the other side. And just go with black. 1, 2, 4. I gained a carbon, didn't I? I did. Yeah, I already had the dot carbon here. Yeah. Yeah, it's confusing enough. That the teacher's making mistakes too. There you go. So yeah, the dot changed color. Right? I'm sorry. Phenyl CH2 C-triple-C. Phenyl CH2 C-triple-C. Now it's an anion because it's been reacted with a base. And we're hitting it with isopentyl bromide in step 4. 4. Bromine attached to 1, 2, 3, 4, V on the end. There, that's isopentyl bromide. More synthesis. I'm going to stop with the red already. I think that's where I'm losing track. There, make sure you got the 4 new carbons in a row. 1, 2, 3, 4 with a V off the end for the 5th carbon. And then the last step is hydration. You can hydrate alkynes 2 ways. Mercury sulfate way or HB-Sia, taken twice way. When it's an internal alkyne, it doesn't matter which way, you're going to get ketones times 2 both times. Ketone on the right, ketone on the left. If it's a terminal alkyne, that's when you have to be more careful. Terminal alkyne, the HB-Sia reaction gives an aldehyde on carbon number 1, and the mercury sulfate way gives a ketone on carbon number 2. That's only for terminal alkyne. We don't have one of those. We're going to get a ketone 50% on carbon 2 here. There's 1, there's 2, and 50% on carbon 3. So the two products, 50-50. Remember, your chain, 1, 2, 3, 4, 5, 6, 7. 2, 4, 6, 7. 2, 3, 4, 5, 6, 7. With a phenyl on the end. Do that twice. Ketone on carbon number 2 for one of them. And number 3 on the other one. Not sure about the numbering? There you go. 4, 5, 6, 7. So get rid of all the answers that have hexanone in them. Not enough carbons there. Those answers were put there for the students who thought benzyl and phenyl were the same thing. Plus, the synthesis doesn't work with the phenyl. Anyway, that's beside the point. So you got rid of the hexes. And you want A and B, don't you? 6-methyl for both, 1-phenyl for both, heptane 2 for this answer, heptane 3 for this answer. So yeah, if two products are formed, you're doing this. But I'll be clear right now. Here's your options for this question. One, just like this, where you get 2 ketones. 2, either an aldehyde or a ketone, but you'd have to have less synthesis. It would be a terminal alkyne. So we don't have a terminal alkyne. Yours might be a terminal alkyne. I can't promise which one you're going to have. And there you go.